and welcome to Statistics. This is a final review. So let's look at this and try to explain what's going on here. Marine biologists are concerned that the pollution from a nearby factory has affected the health of the local sea urchins, which of the following is most likely to be a population of interest. And the population of interest is going to be not the entire ocean, but the ones near the plant, because that's what I'm looking for. Number 2, which of the variables is most likely to be used as quantitative. Quantitative is means numbers and not categories. Country of birth would be like United States, Mexico, et cetera, et cetera. Those would be categories. Zip code would, even though it's numbers, would also be a category because it wouldn't make sense to average them together if my zip code 77584 and 77581. Those would be the categories. Car manufacturer, Ford, Chevy, et cetera, et cetera. Flash drive capacity, 8 megabytes, 16 megabytes, et cetera. That's an actual quantitative number, and I could find an average of them, and that would make sense. All right, number 3. This is asking which one's correct in this sense. First of all, let's see. A says the response variable would be classified as quantitative variable because the variables are options and that act as numerous variables. No, it's not quantitative. Quantitative, remember, are numbers, and this is actually categorical because we're using words, not numerical values, because it's saying good time, bad time. It's not a quantitative, not numbers. It's just set in a category. Number 4, it's asking for the population of interest. And the population of interest is all giraffes, and the reason being is because when you look at it, it says that's exactly what I'm looking for, all giraffes in the wild. And then the sample is actually the 50 giraffes that I am using in the sample, and so that's the 50 giraffes that are captured. So the population is who I'm studying, and the sample is actually the people or the things that I'm actually performing my experiment or survey on. Number 5. I'm looking for the population of interest. Again, this is who I'm studying, and if you read through it, you can see that I go through and it says that I'm looking to study about the children in the United States, and specifically in the United States because if you see that this is talking about 5th grade students, the United States is the only one that does grades the way we do it. All countries have some sort of grade level, but this is specifically the way we do it, so that would be United States. And that's what we're studying. We're not studying the other aspects. Okay, this is the sample. Remember, the sample is what you're actually doing your experiment on, and so when you look for that, you're going to look for a specific number. You see that 462, those are the ones that I'm actually doing the experiment on, so that is going to be my sample. Number 7, it's asking if they're going to be independent, and so independent is going to say if one thing's the probability of one doesn't affect the other. But let's say how many likes cats. So we have 215 out of 213. So the probability of likes cats is 215 out of 335. And the probability who likes dogs and cats, so the probability who likes cats given dogs, meaning it would be looking right here, 172 out of 268. And if these are the same, then it would be yes, because this would be liking cats. There's a formula that says the probability of A given B. If that's equal to A, then they're independent. So when you see this, cats given dogs, meaning every single person in this survey likes dogs. I just want to know the percentage of those that like cats among that. And that's going to be 172 divided by 268, which is 64%. And 215 divided by 335 is also 64%. So yes, they're the same, so therefore they're independent. Number 8, you can see this one ask what percentage of those surveyed as moderates. And so when you see moderates, you go, okay, 149 over 340. And 149 divided by 340 is equal to 43.8%. 149 over 340, and that's about 44%. Okay, number 9. The table shows the companies and what percentage takes the bus. So I go here and I say, okay, bus. So it's 126 over 420. And 126 over 420 is about 30%. I'll tell you the exact. It's exactly, I guess, 30%. This one's saying what percentage of students who like cats. So I have to have this. Also like dogs. So I want the dogs over the cats. So 194 over 215. 194 divided by 215 is equal to 90%. What percentage of laborers take the bus? So then I look again, laborers take the bus. So I have to have laborers, because I'm saying what percent of laborers, so of laborers right here is going to be my denominator of 330. Take the bus, 106. So 106 divided by 330 is going to be 32%. What percentage of moderates? So of moderates means I'm going to have, this is going to be here, and 149 is my denominator. Indicated that medical use of embryonic stem is morally wrong, so I go to morally wrong, so that's 29. And that's going to be about 19.5%. Which is true, so this is skewed to the left because that's the way the tail is, so it's not that one. Which means when you have something skewed to the left, these outliers over here pull it to the left, and so therefore that would mean the mean is going to be pulled to the left of the median. So let's say the mean is smaller than the median, that's right. We should use the median IQR, yes, because it's skewed data, you use median and IQR. So that would also be 2 and 3. So for this one here, this is skewed to the right, and that's yes. The mean is smaller than the median. No, in this case, because the outliers are out here, it pulls the mean because the mean is very sensitive. Because think of like if I have 1, 5, and 10, you can see that that's both the mean and the median until you make that 100. And now 1 plus 5 plus 100 divided by 3 is way bigger. And so now the mean is coming out here, but the median's still the center number. So you can see that that's why that's not true. And no, you don't want to summarize it with mean standard deviation because mean standard deviation is only if it's symmetric. So this one would just be this first one only. Okay, so 2 sections of a class took the same quiz. A had 15 students who had the mean score of 80. B had a section 20 students who had a mean score of 90. So I had 15 students of 80 plus 20 students who had a 90. If I'm going to divide by 35 total students, that will get me my weighted average, and that's going to be 85.7. The advantage of doing a stem and leaf plot is because you can see on the stem and leaf, you can see the individual data values. The other one's not the area principal. Area principal is like when you have data that looks like this and then data that looks like this, and you think, and this is just maybe 2 and this is 4, and you can see that's area principal. You can see that this one actually looks way more than just twice as big. It looks like it's 8 times as big because we're using volume. But so that would be area principal, where that's bad because this is not a good representation of, like, let's say this was how many females were somewhere and this is how many males, and it looks like there's way more by just looking at it when there was just twice as many. And then the stem and leaf plot is when I have this 1, 2, 3, and I have 4, 5, 5, 7. Anyway, you can actually see the values. So that's that one. Number 17, if you want to do gaps and clusters, which one should not? You don't want a box plot because remember, box plot looks like this, and has something like this where you don't see if there's any gaps or clusters in this at all. So that would be what you would want. This is likely to bimodal. Same thing, box plot. Bimodal is something that looks like this, 2 curves. But if it's in a box plot, you wouldn't be able to see that. You wouldn't be able to see the distribution. It's all kind of clumped together. All right, we have a citywide speed limit of 40 miles an hour. If you're caught speeding, the fine's $100. So $100. Right here? Okay, well, it shows it right here. Plus $20 for every mile you go over. So this is showing you how you would do it. Last month, all the drivers were fined for an average 58 miles per hour with a standard. So the mean was 58, and the standard deviation is 9. And it wants to know the mean of the fines. Okay, so to do the mean of the fines, it tells you, since that's the average speed, well, if the fines are $100, say $100, plus 20 times 58 minus 40, because that's the average speed. And then, of course, I'm subtracting, that's the speed limit. And this is the formula they gave me, and then that's the fine, the extra fine for everything over 40. So that comes out to be $460. For number 20, write a brief report. Looking at this, for this one, the answer for this one is C, and this looks Y. It says women appear to marry 3 years younger than men. So you look here, it's like, okay, so you can see everything is like 20, and this is about 23 for the minimum. Look at the maximum, this is about 25, and this is almost 28, so that's 3 years. Everything looks like it's shifted down 3 years, literally. But everything else, the shape looks like it's the same. Like, it just looks like the whole aspect is just shifted. So that's why that one's correct. Okay, for 21, which is true about the weights of the people shown in these parallel box plots. Well, you can see that group 2 is definitely, most people are heavier. You can kind of start to compare things. I'll show you here. Let's look and see, compare the minimums. So the minimums, you can see definitely the minimums in group 2 is heavier. Q1, compare those. Again, heavier in the median. If I looked in the Q3, heavier in Q3, and then even in the maximum. So in general, they're definitely heavier. So, and each person in group 2 is heavier than those in the lighter group of half of group 1. So you look at this, so this is what it's asking. Let's get rid of this here. So you can say every single person here, that's all of group 2. All of group 2 is heavier than, this is half, remember that's 50%, than half of group 1. Than half. Actually, a little more than half of group 1. Okay, for 22, the ages of the people attending a show and a new movie is summarized on an ogive. An ogive is just this right here, where it's showing a relative frequency. Estimate the IQR and the ages. So the IQR is just, the way you're going to do that is you're going to say, okay, 50%. So IQR, if you remember, is 75% minus 25%. So 75%, that's 70. 75% is about here. And then you go down here and you say, oh, well, that's 45. 25% is here. And that's like, I'm just going to estimate and say that's maybe like 28. So the IQR is 45 minus 28. And this is going to give us a closest estimate, because that's going to be about 17. And then I look up here and I see 25% is 15, yeah. So I look here. Does that what ask me? Yes, it did ask me for the IQR. 75 minus 25%. Did I get, yeah, 28? This might be a little lower. Maybe let's take it down to maybe 43. Just a better estimate, because I don't really have any of the ones I looked at them and I thought, okay, maybe my estimate's not great. So I'm like, okay, hold on, that's 13, 14, about 15. So this one's going to be the closest. I mean, it's not going to be perfect, but that's definitely the closest one. But you can see that that's all you're supposed to do, is your 75% mark minus your 25% mark. Okay, for number 23, this is estimate the median. So the median is at 50%, which is right here. And then we're going to say, well, that's that value. So 50% is the median, and that's 22. So that one lined up nicely. Which of the following summarizes changing, adding a constant? When you add a constant, the only thing that's going to change is the mean and the median, not the standard deviation though, because if I have like 1, 2, 3 to my data, then that's the mean, and that's also the median in this case. The standard deviation is approximately equal to like about 0.8, and that's the average distance from the mean. It's so then what happens here is this, is if I add, let's say 5 to everything. And this is now going to be 6 and then 7 and 8. And now that you can see the mean and the median both shifted, but standard deviation is still about the same distance from the mean. So that would not change. And that is, so 24 here. So 1 and 2, which is this one here. There we go. Okay, so for 25, based on the normal model, what two scores between 90% would be losing teams? Okay, so for this one, remember here, I have a sport. It says the mean is 71 and the standard deviation is 12.3. And we did this both on the chart and on the calculator. So I'll show you kind of both. And so it says based on the normal model, between what two scores would 90% of the losing team be? All right, so 90% it's winning this. So if I do this, I'll go, this is going to be 83.3, and then this is going to be above 90, which is good, or guess 90, doesn't matter there. So this is then going to be 95.6. Okay, and I'm looking for 90%. So 90% is going to be, remember this is 50%, smack dab in the middle. Sorry, my drawing's kind of ugly. But 90%, remember my graph, I have this is 68%. But remember, if that's 68% for one standard deviation, then that's going to be 16% and 16%. So this is a total of 84% to one standard deviation. So for this particular aspect, 83.3 is at 84%. So we know it's going to be a little bit bigger than that. And then we look at here, though, at two standard deviations. And for two standard deviations, that's 95% in the middle. But there's 2.5% here. So that's 97.5%. So that's a little bit too much. So I know that it's going to be between, okay, looks like I read this wrong because it's looking for one and another. So it looks like here, hold on a second. Our approximately normally distributed mean of 71 and standard deviation here based on the normal model between what two scores would 90% of losing teams be. Okay, so we're still good. But this here is just giving me as far as 90% of them, and so it's wanting the higher and the lower. So that's the center 90%. So let's redraw, sorry. So it's wanting the center 90% of teams. And so it's wanting this value and this value. Okay? And so for the center 90% of the teams, you know that's at 10%. Or sorry, that's at 5%. And that's at 5% because you can see 5 plus 5 plus 90 is equal to 100. So we're still doing the same thing. I just drew it wrong because the way I read it was what's the 90% time. So I would look up this value and I'd look up 95% in my calculator. So I'd inverse norm on my calculator. And I would do area would be 0.05 for 5%. The mean is 71 and the standard deviation is 12.3. So remember that's menu, probability, distribution, and inverse norm. And so that's how you would do that on that. We did this on a test. You can look up your old test and see it. We did that on a test, and that's what it would be. And you do the same thing then for 95%. And then if you get it out, this is what you would get. You get 51 for the 5% and 91 for the 95%. So that's going to be the same thing here. Okay, so for 26, it says, suppose you have a stats report test your grade of z-scores. You got 2.2 on the exam. Right, explain what does that mean. So that's going to be, the definition of z-score is that it's 2.2 standard deviations higher than the mean. So that's just the definition of z-score. Okay, for 27, we want greater than one standard deviation in a normal model. You have, remember this here, and that's 68%. It asks for one standard deviation. Higher, remember, is going to be 16%. So that's going to be, this one here is going to be 16%. And then, so don't forget this, though, that's 16%. But what I'm looking for is that one standard deviation is higher than how many? And that's a total of 84%. So one standard deviation is higher than 84% of everything. It's lower than 16% of everything. In a normal model, the data is between -1 and +1 for 60% again. You know, I can go ahead and make this out because I've talked about it a couple times. Remember, 68%. 95%, and then 99.7%. So you can see on the one standard deviation, it's 68% in that beginning. Okay, 29, which statement's true? Compared to group B, the weights of group A are closer to the mean. Compared to group B, the groups A are closer to the mean. You can say compared to group B, the weights of group A are closer to the mean. No, because you can see the standard deviation. These are much further apart. And that means the average point is 11.4 away from 128. This is the average point is 8.2 away from 132. So that's not true. A 130-pound person is closer to the average in the group A than group B. Well, 130, you can see it's like, oh, is it closer? Well, that's 130 and that's 130, and like, oh, they're both 2 away. But it's asking 130 with the standard deviation. So this is a smaller standard deviation, so this is why on 29, you could see, yes, this could be true. We don't know if it's a normal model. We weren't told. We don't know. And all people in A, we don't know that either. And number 30, let's see. If we keep track of body temperatures of the next 82 patients at a doctor's office, what do we expect to be true? Few or no patients will have more than 3 standard deviations. That's true, because 3 standard deviations is very rare. It's, remember, at the 99.7. If we did this, that's 99.7% is within 3 standard deviations, and so it's just very rare that 0.15% is outside that. So that's true. That's very rare. The histogram for those temperatures are roughly symmetric. Well, it says it's a normal model, so that's why we know it's roughly symmetric. Exactly? No, we never know exactly. We just have a rough estimate. The correlation, this we know it's going to be negative, so R is going to be a negative number, so you definitely know it is not those. It is really, really close to 1, but it's not perfect, and so I'm going to choose this one here and see that it's going to be very close to 1, but not exact, because all the points are not on the line. And this one here, a correlation of 0 means, the definition of a correlation of 0 means that there is no linear association between the variables. Okay, for this one, the following relationship is a negative correlation. As the number of minutes in 3rd graders spend multiplying, the number of minutes that takes them to complete the quest is going to go down. So as the first one goes up, the second one goes down, and that's the definition of negative correlation. So it would definitely be 1. The speed of a bicycle and the length of the skid marks with brakes applied, well, the speed of the bicycle, as the speed goes up, you're going to have larger skid marks when you stop. So it's just going to be 1. All right, so which is true? If variables are very strongly associated, for this one here, then the correlation is between -1 and +1. Not necessarily, only if they're linear, because they could be like this. They could be strongly associated. As one goes up, the other goes down, but it's not. It has to be linear. The higher correlation between 2 variables is more likely association in cause and effect. We don't know if it's cause and effect unless it's an experiment. And only categoricals, no, only quantitative variables can have a correlation, so none of these would be true. The correlation coefficient between hours a person is awake in a 24-hour period and the hours that same person is asleep in a 24-hour period, well, that's going to be exactly -1, because as one goes up, the other is going to go down perfectly. Because if I'm up for 10 hours, then I'm going to be asleep for 14 hours. If I'm up for 20 hours, I'm going to be asleep for 4 hours. But the total is going to always add to 24. So they're going to be perfectly correlated. Okay, all but one of the statements contains a mistake. Which one could be true? Okay, so the correlation between height and weight is, okay, this is per pound. You can't have units, so no units. The correlation between breed of dog, you can't have categorical data. That's categorical, that's units, so that's wrong. The correlation between blood alcohol level and reaction time is 0.73. The correlation between reaction time and blood alcohol, no. If you switch the units, it's going to be the exact same correlation. So that's if you switch the units, it's going to have the same. The correlation between people's weights and foot length is 0.488. That's the only one that's valid. Residuals are the leftover aspect, where if this is my data, Remember? And then I drew this, I should have done it, I did it kind of backwards. If this is my data, okay, and I draw a best fit line through my data, the leftover from my prediction line, those are my residuals. All right, so residuals is just the difference between the observed responses. This is my observed responses, the actual, and that's and the predicted, and that's my predicted. A positive residual, so you can see the same thing, a positive residual, which is the observed minus the predicted. So observed minus predicted is going to be positive, and that would mean that the final grade would be higher than the model's predicting, yes. This one here is no good because there's a curve in the residual plot, so that's bad. So that is B. This one here, for families who live in an apartment, the correlation between the family's income and amount they pay is 0.6, which is true. In general, yes, in general. You'll notice it says in general. As families have higher income, they pay more rent. On average, not on average, spend 60%. No, that's not what the 60 means. The regression line passed, no, it doesn't mean it goes through 60% of them also. It just means that there's an association between them. Okay, which scatter plot has a strong association, but correlation near zero, and this one is definitely strong because as one goes up, the other goes up, but correlation it has to be linear to have a good correlation, and so that's why it would be near zero. And that's definitely not linear. All right, so what number of meals do they plan on serving? Okay, it says that daily temperature, they served 0.4 on a day when the temperature is 2 standard deviations of mean. So we're going to say 2 times 0.4 because it's 2 standard deviations above the mean, that we're going to go with this one here. A percent growth rate is approximately this. Choose the correct answer. Sorry, what is the percent growth rate with this here? And with this one here, it's like, well, in an exponential model here, you won't be having the exponential models on your test, but the answer here is 29. And you can, if you do have, this will be given to you on your test though, because the percent growth rate is the exponential model here, and all you would have to do then is solve based on your rate, and so of course you could put that at 0. X would be 0, and you plug it in, and that's where you're going to get 29 from. Percent decay, so for this one, the same thing. If you put 0 in for X, again, you'll get 33, just in your calculator. Okay, so for 45, you won't be asked for these as well. Growth stock market average 9% a year. The model, it's going to be exponential because it keeps going so high. Exponential also, this won't be on there as well. I'm not going to have any of these. This is linear. As one goes up, the other goes up, but that one won't be on there either. So for this one, which is a statement about residual plots of linear models is true. So for residual plots, you can have a curved pattern of the points is nonlinear. So this is, if it's something like that, yes, that's nonlinear. A random pattern suggests yes. And you want a random pattern because it's the leftover, and you want something just can't put another model in there. And so those are both true. Again, on this one, what's true? So for 49, you have the people that did not respond are likely to be similar to those, so you shouldn't take them in the sample. No, we don't know that. That's not true. This suffered from non-response bias because only 30% of the teachers took the survey. Not everybody took it, and so yes, that is non-response bias. This is not census because it's not sent to the entire population, and not everybody did it. So for 49, the answer is 2 only. A chemistry professor teaches a large lecture and gives a survey about how it can make it more interesting. He's hoping to get more people to attend his class. However, guess what? People that didn't attend his class are not taking the survey, so that's under coverage. Which is an advantage is a stratified sample instead of a simple random sample. So a stratified sample is going to put it in separate groups. First, let's say group A and group B, maybe boys and girls or something, and then doing a simple random sample in both ones. So you can see For here, the stratified sample allows you to get information from each stratum, which each group. 52, 50 randomly chosen students represent their high school, as well as 50 randomly chosen adults represent the entire country. And that would be okay if I showed this one here. As long as the sample is large enough, it doesn't have to be randomly selected. No, that's not true. Undercovered results when sampling frame is not the same as population. Absolutely. For instance, if I was trying to do Dawson High School and then I actually talked to people from Pearland High School, maybe they were over at Dawson and I surveyed them. Well, that would not be appropriate because if my population's Dawson High School, all my people have to be from Dawson High School. So the population of interest is all U.S. adults, and that's what it's looking for, all United States. Yes, 41% is a statistic. It's right there. Yes, because it's from the data. And then the sampling design should provide a reasonable estimate. Yes, because I have a random sample, and my random sample is nice and big. All right, so for this one, 1/3 of these return the survey, with 44% indicating they found a lower price elsewhere, which is true. So I have 1 and 2 only are the answers here. The population of interest is all buyers because you can see that he's hoping to find them, and so what he's doing is he's trying to look for something about all cars. And but however, this is non-response because I only had I did not have a lot of people that wanted to actually do the survey because only 1/3 of them returned it, so that's non-response. And this is just not true. So 1 and 2 is the one here. All right, so for 55, 4 students will be chosen at random to represent the state conference. What's the probability? There'll be 1 junior and 3 seniors. So we have 4 juniors and 8 seniors. So I have 4 juniors and I have 8 seniors. And I'm choosing 1, 2, 3, 4. And I have 4 juniors choose 1 times, I have 8 seniors choose 3, and I have a total of 12 choose 4. So if you put this into your calculator, which you can do NCR, 4, 1 times NCR 8, 3 divided by NCR 12, 4. That's going to be the answer. The NCR, by the way, remember, is menu, probability, combinations, or you can type in NCR. And let's see, the answer for this is 45%. Independent events, one does not have an effect on the other. Registering to vote and being left-handed are not going to have an effect on each other. All the others have some sort of relationship together. 57. If the coin is fair, how many heads does the second friend expect to have for the first friend when she's 200 tosses? So I have 40 tosses and I had 16 heads. And I know that's about, that's a little less than 50%. In fact, it's 40%, right? And all of these others don't make sense because then out of 200, we expect to have about 100. But we're not going to have 100 exactly. 100's 50%, so we know it's not that one because it's already under a little bit, but we're going to have more tosses. We expect for it to be 96 because 96 out of 200, 96 out of 200 is a little bit higher than what we were at, which is about 48%. But 116's way over, and we're already underestimating, and 80 out of 200 is still at 40%, but I flipped it so many times, and even this is short term. The longer term is going to get closer and closer to the actual probability of 40%, or 50%, excuse me. The serial number on the car, 58, let's see, is this one here, and we have 3 letters and 4 digits. So I have letters, I have 26 letters in the alphabet, choosing 3, times I have 10 digits to choose from, 4. But then it says here, the first number can't be 0. So I could do it, I can do it like this, 3, 1, 2, 3, 4. Let me just do that out like this because I think it'll make it a little bit easier to follow what I'm doing. So this is 26 times 26 times 26 combinations, but then this can't be 0, so that's times 9 times 10 because all the other ones can be 0. And that's what you get. So this one wouldn't be 20 choose this because I don't have this. This would be actually 10 choose 3 and then times 10 choose 1 because I have one more. Or excuse me, 9 choose 3. All right, and so this, which expressions are equal? So I'll show you what this looks like. 12p3 is going to be 12 factorial over 9 factorial. 12c3 is going to be 12 factorial over 3 factorial times 12 minus 3 factorial, which is 9 factorial. That is from 12 minus 3 from the formula. 12(9) is the same formula. We have 12 factorial over 9 factorial, and that's 3 factorial. The 3 again is that 12 minus 9. And you can see definitely that these so far are the same. And then this one here, 12p3 over 3, is going to be this where I had here of 12 factorial over 9 factorial that I had in the first one, but then it adds another 3 factorial. Sorry, that's in there. So that's identical as well. So these three are the same. And the last one, which of the following situations is a combination? And a combination is going to be this one where a lottery has 6 numbers and they can play out of 80 or 48 because I have a because I can the order doesn't matter. Like once I give them the numbers, that's it. I'm selecting only 6 numbers and I'm saying, hey, here's my numbers. And if the numbers are there, they're there. All right, I hope that helps and good luck on their final. Remember, you can use your notes on the final, so take good notes from this video.